The next thing to talk about, well, you would have thought that after having done the product rule, the next most complicated thing to talk about would be quotients, right? However, it turns out that you can find a rule for the quotient by using the product rule together with the chain rule, and that's why I delayed until now saying the quotient rule. Now, in fact, I tend personally not to use the quotient rule because I don't remember things so great, and so I like to know the fewest things that I can get away with knowing. And so since I know the product rule and I know the quotient rule, I just memorized that. I never actually memorized the quotient rule, which is this down here if you want to know what it is. If you want to know the derivative of f over g, it's this. And it's ugly, and I don't like it, and I refuse to memorize it. And but if you're just wondering what the quotient rule is and you don't care about the proof or any other method, then here's your answer, and you can end the video here. But personally, I like to regard the numerator as getting a -1 power and flipping it up to the top. That's a legitimate algebra rule. And now I take the derivative of the product, so that's product rule. And so here, in this particular example, I would take the derivative of the left, multiply by the right, leave the left derivative of the right, and then algebra, algebra, algebra. This is what comes out at the end. Now that was fairly easy because the derivative of x to the -1 could go just by the power rule, right? A fairly simple rule. Let's take a look at tangent and see how you could get its derivative using the fact that it's sine over cosine, where, now we can't use the power rule on that denominator, and it's a little bit harder. So here's the derivative, right? I flip that denominator up to the top and give it a negative exponent. I go ahead with product rule and say derivative of sine is cosine, leave the right thing alone, leave the left thing alone, take the derivative of cosine to the -1, which, if you want a sort of fully spelled out use of that tabular method that I showed you before, it's down here. But at the end of the day, the derivative is this thing down here, and that's what I have transcribed up here. Now, if you do all your due diligence with algebra, you'll know that this is cosine over cosine is equal to 1, and this simplifies to sine squared over cosine squared, which is tangent squared. And a trig identity comes up yet again, 1 plus tangent squared is equal to secant squared. So that's the derivative of tangent. The derivative of tangent is secant squared. Now, to just kind of finish off the video, I'll give this quick proof that of the quotient rule, right? So here's the proof of the quotient rule. So we're looking for the derivative of f over g, and I just as in the method I described, right? The proof just goes by the method I told you. I take the derivative of f, leave g alone, and leave f alone, take the derivative of g to the -1, right? The reciprocal of g, not the inverse function. That's kind of unfortunate overlap of notation. But anyway, now I know that ultimately I'm going to want to add fractions, and I can kind of see into the future and save myself a bit of typing if I right away go ahead and put g back down into the denominator, and on top of that, multiply top and bottom by g. So that's what I'm doing, going from here to there. Over here, I compute the derivative of reciprocal of g with the chain rule. So what does the chain rule say? It says take, the inner function is g, the outer function is x to the -1. So how do you take the derivative of x to the -1? You drop that -1 down, you subtract off the exponent, and then you multiply by the derivative of the inner function. Now, a few steps of algebra gets you the next equation, and we're done proving the quotient rule.